This is Year 13 AS1 and this is Physics 1 and it is a selection of past paper questions on motion. So the first question is from AS1 Jun2003 and we'll just make this a wee bit bigger so that you can see it a bit better. The first question says to define acceleration, or ask you to define acceleration. So you know that acceleration, the easiest thing to do is write down is the rate of change of velocity. Now you could also say A is equal to V minus U over T, but you have to define all your terms, otherwise they're not going to give you your mark for that. So of course U is initial velocity, V is final velocity, T is time and A is acceleration. Part B. Figure 3.1 is a simplified sketch graph of a velocity V against time T for a train as it travels along the straight track between two stations. And so you can see it's a VT graph. Always make sure that you're reading the axes properly. And you can see it's a straight line, which we know represents a constant acceleration. Then it is a flat line, and that represents a constant velocity of whatever that value is. And then there's a line going down, so it's a deceleration, and it's constant again. So it's very important that you make sure that you put in the words constant in there if that applies. And in the first one, of course, it does. So it's a constant acceleration from T1 up to T2. From T2 to T3 is a flat line, therefore it's a constant velocity. And for the last part, this time it's a deceleration, and again it is constant. So it's a constant. It would be a slope if it wasn't constant. Sorry, that's a deceleration. Right, part 2, state how the distance between the two stations could be deduced from figure 3.1. And that, of course, in this graph is the area underneath the graph. Now, they're quite happy that you would shade that area, so it's maybe a good idea to shade it. And you could say calculate the area of the shaded part of the graph, or just calculate the area between, you'd have to be quite specific there, between the line and the x-axis or time axis. And there's the alternative, calculate the shaded area. Now another alternative there, I suppose, is that you could use S equals half U plus V times T, but you would have to do each part separately. Initial velocity of 0, final velocity of whatever that is. You'd have to do it in 3 parts if you wanted to do that, because the acceleration isn't constant the whole way there. So that is another alternative there. All right, part C of the question. It says, in this part, neglect air resistance. A boy throws a ball straight up into the air. It reaches the maximum height and returns to the thrower's hand. Take the upward direction as positive. So if we draw a wee diagram here, maybe, the upward direction is positive. So going up the way, up to there, is a positive direction, but the downward direction is negative. Now you have to think what happens as the question asks you what gives the correct values of acceleration of the ball at the various stages of motion. And despite the fact it's moving in a positive direction, its acceleration when it's been thrown up is always directed towards the ground, because it's always slowing down there. So its acceleration there is minus g. Its acceleration at the top as well is still also minus g, because it's still wanting to get back down to the ground. And in the negative direction, although its acceleration is plus g, a plus and a negative make a negative. So altogether, the acceleration everywhere is minus g on the way down. So I might say that again. It's got a positive acceleration on the way down, but it's moving in a negative direction. So overall, it's got a negative g. And therefore, the answers are minus g, and minus g. And even if you don't understand that, it's really worthwhile knowing that answer is always minus g. It's only worth 1 mark anyway. Next part of the question, the ball reaches a maximum height of 8.6 metres above the boy's hand. With what speed does he throw the ball? So this is just an equation of motion question, because we know it's got a constant acceleration or deceleration due to gravity. And so therefore it reaches the maximum height. So the maximum height S is equal to 8.6 metres. At maximum height, you always know final velocity is 0. We're looking for the speed he threw the ball at, and we know that acceleration is minus 9.81. And so the obvious equation to use with that is v squared equals u squared plus 2as. And when you put the numbers in, then it's u we're looking for. Remember to put in a minus 9.81, otherwise you'll come out with a negative answer overall by 8.6. And so when you bring this part across, this part's negative, you bring it across equal sign, it becomes positive, and that value, I haven't it written down, but so u squared is equal to, I'll just write the brackets again, 2 by 9.81 by 8.6. And because of the minus coming across, it becomes plus. That's a bracket around that. And then u comes out to have a value of 12.98. Or to two significant figures, that comes out as 13.0 is the answer.